Okay, so let's continue our discussion. So we have transformed the word problem into a linear programming model, and after that we will discuss how to solve the word problem from the linear programming model. So the first step in solving linear programming problems is to convert the word problem into a linear programming model, which we already did in the previous video. So you identify or set the decision variables, identify the objective function, and enumerate the constraints. Okay. For the second step, we will graph using Desmos and determine the feasible region. Okay. Now do not forget to click the corner points. So to do this, from our LP model, let's encircle the constraints. Okay. So for our constraints, we will treat this as a system of linear inequalities. Now let's recall that in the review, we can graph a system of linear inequalities using Desmos. So the idea is we will graph the system of linear inequalities using Desmos, and this will be the finished product. Okay, so you have there the shaded region and the corner points. Do not forget to click the corner points as this will be important later. Now the shaded region is called the feasible region. The feasible region represents the set of all points that satisfy our system of linear inequalities. In other words, the feasible region contains all the points that satisfy the constraints. So let's enumerate our corner points. We have 0, 0. We have 2000, 0. 1333.333, 666.667, and 0, 1428.571. So these are the corner points. After identifying the corner points, the next step is to apply the corner point principle. Okay, what is this corner point principle? The corner point principle states that the objective function is optimized at one of the corner points. So let's recall our linear programming model. Take note that in that model, our objective function is to maximize the profit. The profit is 2x plus 3y. So using our corner points, we substitute these values to x and y, and we will get the following profit values. Now, which among the corner points maximizes the profit? Okay, observe that among the points, okay, the third one maximizes the profit. So this serves as the solution to the linear programming model. Take note that X represents the number of dolls and Y represents the number of toy cars. So to solve this problem, we make conclusion. Thus, the store owner, in order to get maximum profit, must have 1,333 dolls and 667 toy cars. We use 1333 because there is no concept of 1333.333 dolls. Similarly, there is no concept of 666.667 toy cars, so we use 667 toy cars instead. If this is the case, the maximum profit will be equal to 4,666.667. So this is the solution to our first example. In the next video, we will discuss a second example.